Hello, good afternoon, everyone. The authors and invited guests, welcome to the technical session 10E. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held the day before yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today. It is 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. Please note that on the 7th minute, I will raise a gentle reminder. There is another request to all the participants that you all are requested to kindly stay with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. Just before we start the session, I would like to introduce to you all the chair of this session, Dr. Archana Satish Bannett. Dr. Archana is an assistant of professor in the Department of Computer Engineering at METS Institute of Engineering. She has 19 plus years of experience and has organized various workshops and seminars. She has also published 8 papers of international repute. We welcome you to the session, ma'am. Would you like to say anything before we start with the presentations, ma'am? Okay. So moving along, we'll start with the presentations first. Now I would like to call upon our first presenter, Rajiv Kumar, presenting on the paper titled Anuvad, Integrating Technology and Indigenous Languages. If you are available with us, I request you to kindly take over this session with your presentation, please. Hello.
So good afternoon, everyone. I am Rajiv, and thank you for giving me the opportunity to present our work on Anuvad, integrating technology with indigenous languages. So this project aims to bridge the linguistic divide in India by making multimedia content accessible in regional languages. So as we know, India is a land of incredible linguistic diversity with over 122 major languages and thousands of dialects. Yet, most online content, especially videos, is available only in English. This creates a significant barrier for non-English speakers, limiting their access to information, education, and entertainment. So our project Anuvad addressed this challenge by leveraging cutting-edge technologies like machine translation, speech recognition, and text-to-speech synthesis. The goal is simple but powerful: to translate English video content into Indian regional languages, making it accessible to everyone, regardless of their linguistic background. So what is the problem and our approach? Like on one hand, India's linguistic diversity is both a strength and a challenge. On one hand, it reflects our rich cultural heritage. On the other hand, it creates a barrier to accessing information. Like for instance, a student in a rural area might struggle to understand the educational video in English, or a farmer might miss out on crucial agriculture advice because it's not available in their native languages. This digital divide disproportionality affects marginalized communities, limiting their opportunities for growth and development. To solve this, we developed Anuvad. How it's work? Let me walk through how Anuvad works in practice. It's basically works in the total of 4 phases. First, audio separation. We start by extracting the audio from the English video. This is done by using an open source tool called FM um, MPEG, which is known for its versatility and compatibility with various multimedia formats. Now comes the phase two, which is speech to text conversion. Next, we convert the spoken English into text. For this, we use IBM Watson speech recognition system, which is highly accurate and efficient. To speed up the process, we break the audio into smaller chunks and process them in parallel, which reduces the time up to 70%. Next phase is machine translation. Once we have the English test, we translate into the desired regional languages using Google Translate API. This ensures high accuracy and fluency in the translation. Now comes the last phase, which is text-to-speech synthesis. This is done by Flight text-to-speech engine. This speech is then synchronized with the original video, creating a fully translated version. Uh, what are the results and its impact? We tested the system on 15 English videos covering a wide range of topics in different languages. Uh, our average, the system achieved approx 79% accuracy rate, meaning the translations were faithful to the original content. Now, this is a brief analysis. And now, what are the future scopes and limitations of this project? While Anuvad had shown promising results, it's not without its challenges. Let me walk you through some key limitations and our plans for future improvements. First is handling multi-speaker conversation. One of the current limitation is handling videos with multiple speakers. The system generates a single voice for all speakers, which can feel unnatural. To address this, we are exploring speaker diarization techniques which can identify different speakers and assign unique voices to each. Second is expanding its language coverage. Currently, Anuva supported limited number of Indian languages, but India has many more. We plan to expand the system to include more regional and minority languages. Third, real-time translation. Based on user feedback, one of the most requested feature is real-time translation. And there are some cultural nuances and emotional undertones also. So these are some of the future scope that we can look into it, and this enhancement will make Anuvad more robust, inclusive, and user friendly. So these are our co-authors. So I would like to conclude by saying that Anuvad is more than just a translation tool. It's a step towards a more inclusive and equitable digital future for India. By leveraging technology, we can break down linguistic barriers and ensure that everyone, regardless of their language, has access to the wealth of information available online. This project is a collaboration between technology and culture, and it holds immense potential to empower marginalized communities, foster cross-cultural understanding, and promote equitable access to knowledge. Ultimately, our vision is to create a world where language is no longer a barrier to information, education, and opportunity. Thank you for your attention. I'd be happy to take any questions you may have.
I think ma'am's mic is not connected. I'll just connect with her, and for now we can continue.
Now we'll jump on to the next presenter. Thank you so much, sir, for sharing. Our next presenter for the session is Shubham Kadam. Sir is presenting his paper on the title Artificial Intelligence in Organizational Culture Assessment, Transforming Insights and Strategies. If you are available with us, I request you to kindly take over the session for your presentation, please. So, Shubham Kadam, if you are available with us, we request you to kindly take over with your presentation, please. Okay. As we don't have him present right now, we'll jump on to the next presenter. Our next presenter is Sakshi Sharma. Her paper is titled Development of Flutter Mobile Application for Real-Time Plant Disease Detection Using Convolutional Neural Networks and TensorFlow Lite. We request you to kindly take over the session for your presentation, please. Ma'am Sakshi Sharma, if you're available, we request you to kindly take over the session for your presentation, please. Have been connected. There is some problem. So we'll take on point for the next presenter. Our next presenter is Utkarsha Wangari, presenting a paper titled Gamification in Human Resource Management with Artificial Intelligence, Enhancing Engagement and Productivity. If you are available with us, I request you to kindly take over with your presentation, please. Do we have Mr. Ankit, our that sir?
Yes, I am present, ma'am.
Yes, sir. So, sir, we'll start with you for the next presentation. Sir
Sure,
is
sure.
going to be presenting his paper on the title Machine Learning Based Advanced K-Means Architecture for Grass Quality Recognition. Sir, I request you to kindly take over the session for your presentation.
Thank you, ma'am. I'm going to be share my screen.
Yes.
Just a minute. Is it visible, all of you?
Yes, sir, it is visible to us.
Thank you. Good afternoon, Dr. Rachna ma'am, session chair, and all the present members in this conference. I, Dr. Ankit Bhavsar, going to be present the paper on machine learning based advanced K-mean architecture for the grass quality recognition on the behalf of my research scholar, Miss Alpa Barar. Due to the medical emergency, she is not able to be present, so I will be take that opportunity, and I'm going to start with this one. These are the points which we are going to be discuss throughout the presentations. That is the research contributions, introductions about the entire domain that we want to do a research, did a research, then proposed the architecture for the grass quality monitoring, result analysis, and what will be the what was the outcome that I'm going to be discussed throughout the presentations. Basically, the grass is one of the most important food for the animals. The quality of grass is most important to be healthy life for the animals. So this is an objective. Now the day to day, the land and soil fertility is going to be deteriorated. Based on that one, the quality of the grass is going to be also be deteriorated. So there is nothing, or there is no availability of any such kind of the survey which shows that okay, the grass quality is fine based on the some parameter. So me and my research scholar take that opportunity. Based on the k-mean algorithms, we identify the grass quality, whether it's a fresh or not, with the different kind, implementing a different kind of the filters. That is our purpose to the entire research. Introductions that I talk about, that grass quality measuring and identifying the grass quality, whether the grass is fresh or not. Based on that one, we can be identify that the whatever the consumptions by the animals is good quality of the grass or not, we can be identified on the entire research. What we use the k-mean plus algorithms to identify the color of grass, to identify the grass quality and the grass freshness. We use the k-mean algorithms, k-mean plus algorithms. Along with that, we used the two different kind of the filtering mechanism. The one is a median filter and the linear filters. Based on that one, we clear the noise from the images, and then after we implemented, we are implementing a keep mean plus algorithm. This is the entire the process flow through which we identify whether the grass quality is good or not. Basically, whenever the grass is cut down from the farms, basically early morning at 4 or 5 p.m. A.m., then we take the photographs of that grass. That photographs is going to be resized one depending on our requirement, and that photograph is ultimately a image. We implemented that image clarifications or clarity algorithm, that is a median filter algorithm or one year filter algorithm, because if we implement only single one algorithms, the grass color is going to be a change, a slightly or minor changes on over that. And our entire research is focused on the color of the grass, which identify whether the grass is fresh or not. So we use the two different kind of the algorithm. First we implemented the augmentations, then after median filter one, and then linear filter one. Once we get the exact image of the grass along with the perfect color of the glass which actually scenes and the photograph scenes, and then we implement the key mean plus algorithm that will be identify the RGB format. And we have a set of data set where we identify this is the RGB range where the grass is considered to be fresh, or the range of the RGB format is considered to be a non-fresh one. So this is an entirely hybrid approach. We use the median filter to removing the noise like Gaussians, randoms. We use the winner filters, and we use the k-mean plus plus color clustering algorithm for the identifying the RGB color range. This is the way we did the entire process. Then after, what we get, we start with that one. We get the three range for the quality of the grass based on the RGB format, that is a good, moderated, and the poor quality. The RGB format color 62, 66, and 19 is considered to be a kind of good grass or the fresh grass kind of the things. This is a simple photographs which we taken during our research one. Good quality of the grass, moderated, and the poor one. This kind of the photograph we are implementing the cleansing mechanism, that is a what median filter and the linear filter, and after that we implement the k plus plus one. So what we get the output, we get the output something like that one. If we implemented augmentations, what we on the cluster of 5, 10, or 20, we get that accuracy for the median filter one and for the linear filters one. This is the outcome one. Based on that one, we identify the color format, that is an RGB. That you can be see that the good color format of the RGB, moderated one on poor one. This is the used by the k-mean plus plus algorithm. And in future, any image of grass we provided to the entire system will be identified that whether the grass is a fresh or the moderated one or the low quality one. This is a something output what we received from entire process. We get the RGB format, that is a dark base, average base, and the threshold value. What we identify for the fresh grass is in the RGB format is a 62, 66, and the 90. R stand for 62, G for 66, and the 19. That is a range where we consider that it's an moderated kind of the grass, which is not fresh as well as not the non-fresh kind of the grass. This is the accuracy ratio for the all the filters what we received. That is for the median, that is a 43 percentage, Viner, that is a 44 percentage. And we finalize the RGB threshold value for the good quality of grass, moderated quality of the grass, and the poor quality of the grass. Thank you, all of you.
Thank you so much, sir. Ma'am, is the issue with the mic has been resolved? Would you like to ask any questions? Okay. So we'll move on to the next presenter. For our next presenter, we have Vatsal Jain presenting on the title Reducing 5G Modem Costs Through Virtualization, Leveraging SDN, NFV, and Open RAN for Efficient, Cost-Effective Design. If you are available with us, I request you to kindly take over the session with your presentation, please.
Yes, ma'am. Uh, I hope you can see my screen.
Yes, sir, it is visible with us.
Good afternoon, everyone. It's a pleasure to be here today. I'm excited to talk about something that's shaping the future of mobile communication, reducing 5G modem costs through virtualization. As 5G rolls out globally, cost remains a major challenge. In this presentation, I will show you how technology like SDN, NFV, and OpenRN can help make 5G modem more efficient, affordable, and scalable. Let's dive in. Let's talk about why this research matters. We all know 5G is the future. It's fast, reliable, and support everything from Ultra HD streaming to smart cities. But there's a problem. Traditional 5G modem are expensive to build, difficult to scale, and costly to maintain. If we want to widespread 5G adoption, we need a smarter, more cost-effective approach. And that's exactly what virtualization offers. Moving from rigid hardware-based design to flexible, software-driven solution that cuts cost without sacrificing any performance. First, let's talk about evolution of mobile networks. To understand why this shift is necessary, let's take a quick look back. 3G introduced mobile internet, 4G gave us streaming and app-based services, and now 5G is unlocking things like real-time AI, remote surgeries, and autonomous vehicles. But here's the catch. These advanced application demand a network that is not just fast, but also affordable, scalable, and energy efficient. That's where virtualization comes in. Before talking about virtualization, let's talk about what's the challenges in the traditional 5G modem. So the problem with the traditional 5G modem is that they are rely too much on a specialized hardware, custom built chips, proprietary components, and fixed architecture. These drives up production costs, makes manufacturing more complex, increases power consumption. Even upgrading them is a challenge because hardware isn't as flexible as software. So we need a better way. Virtualization, the solution. So what if we could take many of these hardware function and move them into software? That's exactly where the virtualization does. Instead of relying on expensive, dedicated hardware for tasks like signal processing and baseband operation, we use general purpose processor and software-based solution. This makes modem cheaper, easier to update, and more adaptable to future technologies. Let's talk about OpenRAN. This is going to be a game changer. Another big breakthrough is an OpenRAN. Traditionally, telecom operators are locked into specific vendor because of proprietary hardware. OpenRAN changes that by allowing operators to mix and match components from different vendors. This is not only reducing cost but also foster innovation and competition in the industry. In short, it gives network operators more control and flexible over their infrastructure. Cost saving and with virtualization. Uh, uh, okay, let's talk about cost saving here. Let's virtualization bring real measurable savings. It can cut the bill of material by 33 to 37%, manufacturing cost by 30%, and energy consumption by 40%. Even maintenance costs go down up to 25% because software-based updates eliminate the need of physical repairs. Overall, we're looking for potential 35% reduction in total modem cost, a huge leap towards making 5G more accessible and affordable. Now let's talk about traditional and virtualization 5G modem. See, in traditional, hardware is very intensively designed with specialized components, whereas 5G modem are software based. That's why we can update and we can do whatever we want with cost saving technologies. As we talk about the cost saving with the virtualization, here's a breakdown for different costs as I told you earlier. Now let's talk about network slicing. Cost saving aren't the only benefits. Technologies like network slicing and edge computing makes 5G even more powerful. Network slicing allows operator to create virtual network optimized for different needs, whether it's high speed streaming, mission critical application like remote surgeries, a massive IoT networks. Meanwhile, edge computing reduces latency by processing data closer to the user, which is essential for application like autonomous vehicle and AR in VR. Now let's talk about as we're talking about the edge computing. Edge computing is a distributed computer framework that processes data closer to the end user, as I told you earlier, and at or near the source of data generation. It has many advantages. Some of our I mentioned here is reduced latency, decreased network congestion, and enhanced reliability. Now let's talk about the real world application, and this isn't just theoretical, it's happening right now. Virtualization 5G modem are already proving their worth in real world application, from enhancing IoT deployment to powering next gen immersive experience. As we move towards a more interconnected world, virtualization will key to making 5G networks smarter, more efficient, and more affordable for everyone. Now let's talk about advantages of virtualization. To sum it up, virtualization is a win-win. It reduces cost, make network more scalable, improve energy efficiency, and allow for faster upgrades. Instead of being locked into a rigid hardware, telecom provider can now build flexible software-driven 5G networks that adapt to future needs. In conclusion, virtualization powered by SDN, NFV, and OpenRN is revolutionizing 5G modem design. It reduces cost, increase flexibility, and support efficient resource utilization. And thank you so much for your time. If there are any question you may have.
Thank you so much, sir, for presenting. Ma'am, do we have any questions for sir? Uh, Actually, our chair is having some trouble with the mic. Ma'am is working on it. No worries. What we'll do, we'll meanwhile go to the next presenter. So thank you so much, sir, for presenting your presentation. We'll go
Thank you
on
so
to
much.
the next presenter. Okay. Our next presenter is Mallu Praneeth Reddy. So, sir is presenting a paper on the title Regression Techniques for Calorie Prediction, a Comparative Analysis. If you are available with us, I request you to kindly take over the session with your presentation, please.
Hello,
Hello, sir.
am I audible?
Yes, you're audible. You. Hmm.
Afternoon, everyone. Myself, Pranit, and I'm here to represent paper ID 605. That is regression techniques for calorie prediction, a comparative analysis. Coming to the abstract, the paper aim is to predict the calories burned by a person using machine learning models, linear regression, random forest regression, XGBoost, and CatBoost, based on several factors like gender, age, height. In addition to the predictions, the analysis also compares algorithms based on several performance metrics like mean absolute error, mean square error, and R2 score. And hence, based on these performance metrics, we can determine the most effective algorithm for calorie prediction. So before going to introduction, generally a calorie can be defined as the amount of energy exhausted to do any type of physical activity. In other scientific forms, we can define a calorie as the amount of energy required to raise a temperature of 1 gram of water by 1 degree at STP conditions. Now coming to introduction, many individuals generally perform physical work. Many individuals generally perform physical works to burn calories and maintain good physical health and weight. All of them wants to know the outcome of their workout. So by using these regression models, they can track the insights of workout and can analyze which type of exercise and duration are most effective to reach their fitness goals. Going forward to methodology, this is the typical flowchart that is used to build any type of machine learning model. The first step of this is this analysis is dataset acquisition, that is collection of all the required datasets that are required to build the model. We are using two datasets in this analysis, that is calories.csv, which represents the user IDs and their respective calories, and the other one is exercise.csv, represents the calories burned by an individual and their respective gender, height, weight, and all other factors. The second step, transformation of a dataset so that it can be used to build a machine learning model without much complexity. It includes many tasks like encoding the categorical values into numerical values, because most of the machine learning models work only on numerical values, and handling the missing numerical and categorical values. Coming to this analysis, we are in this analysis we are going to drop the future user ID because it has no impact on the target variable. Then we will transform the categorical variable gender into numerical variable. I mean, we will map it with 0 or 1, and then we will replace the missing numerical values by using main criteria and missing categorical values by mode criteria. The next step is to split the dataset into training and testing parts, in which the training part consists of 80 to 70% of the entire dataset, and testing consists of 20 to 30% of the entire dataset. As I said before, we are going to use four types of models in this comparative analysis. The first one is multiple linear regression. So basically, linear regression is a baseline model that establishes a relationship between multiple independent input variables and a dependent output variable. It performs well on straightforward datasets with a linear relationship between variables. The next one is random forest regression model, which is an ensemble learning model. Coming to working of random forest, will initially train all the decision trees parallelly with the input data set, and later in the testing phase, each decision tree will produce its outputs, and for the final prediction is calculated by calculating the averages of all prediction for regression tasks, while the most repeated prediction is calculated is decided as the final prediction for classification tasks. The next model is XGBoost. XGBoost is an extreme gradient boosting framework, in which initially we will train the first baseline model with dataset, and we will train the subsequent decision trees sequentially with both the datasets and residual errors of its previous decision trees. The final and the final prediction will be calculated by the sum of initial prediction plus the final model is CAD boost, which also uses a similar framework of gradient boost, but it is also tuned for dealing with categorical data by translating categorical values into numeric values on itself. CAD boost has several other additional features, like it uses symmetric trees and not only stumps, it uses symmetric trees and ordered boosting to prevent overfitting and improve generalization. Especially, it is used for high dimensional categorical datasets. Moving to model training and testing. The initial phase of building a model is known as training phase, where the model gets to train with input features and output labels of the training data, allowing the model to recognize the hidden patterns or relationships between the inputs and outputs. This training phase is followed by the testing phase, where the model is tested with input features of testing data, allowing it to predict the output. Moving to output, the performance metrics of regression are mean absolute error, mean square error, and R2 score. Mean absolute error and mean square errors are more general for regression tags, but R2 score is a statistical coefficient that decides how well the model fits the data, and it explains how well the model describes the variability in the data. As we can see the comparison table of all these models, we can observe that MSC and MAE are high for multiple linear regression, while they both are low for CAD boost. So basically, MSC and MAE should be as low as possible for a model to be efficient. For the model to be efficient. So the MSC and MAE are low for CAD boost, high for multiple linear regression, and R2 score is low for multiple linear and high for CAD boost. The first graph depicts the actual versus predicted calories burned based on multiple linear regression. We can observe that for the actual value 0, the predicted values of multiple linear regression ranges from -50 to 50. But in the case of CAD boost, we can see that the predicted values of CAD boost are around 0 only. Similarly for all the types. These are the actual versus predicted values depicted by the CAD boost algorithm. We can observe that the values are so near. As I said before, as the R2 score value is high and other or low for CAD boost, we can consider that CAD boost is the most effective model for calorie prediction, while multiple linear regression is least effective model because its MSC and MAE are too high. Coming to applications, we can use these models for weight loss planning as they can track the calories. An individual can maintain his calorie balance based on his plan, and we can also implement them in wearable smart fitness devices, and we can also use them in medical and clinical settings to suggest and track several physical programs for patients like obesity patients and all. Coming to future scope, we can improve, we can adding features like target weight, preferred weight, and what types of exercises and all. We can suggest a personalized health and fitness program for every user. And also we can make the model resistant to environmental factors by adding several factors like temperature and altitude. These are several references and previous works which I followed to write and implement this project. And thank you for your attention.
Thank you so much, sir. Uh, yes, we have a question from ma'am, our session chair, Dr. Archana. Ma'am has
Oh,
written the question in the chat as well. How do regression techniques handle non-linear relationship in calorie prediction?
no, only the first one can't handle. That's why it's MSC and MAE are too high. I mean, only multiple linear regression can only not handle, but the later one, the XGBoost and advanced one can handle.
Okay. Ma'am, are you satisfied with the answer? Okay. Thank you so much for your presentation, sir. Now we will go on to the next presenter for the session. Thank you. Our next presenter is Mr. Prashant Vats, presenting on the title Smart Contract Based Validation of Intrusion Detection Systems in Blockchain Networks. If you are available with us, I request you to kindly take over with your presentation, please. So I don't think we have sir over here in the meeting. We'll jump on to the next presenter. And I'd like to call about the next presenter. Our next presenter is M. Nanda Kumar, presenting the paper on the title The Influence of Adverse Weather on the Reliability and Performance of Autonomous Vehicles. If you are available with us, I request you to kindly take over the session with your presentation, please. We don't see the presenters here right now, so we will call out her presenter, Ms. Sakshi Sharma. She had trouble with the mic before. I request you, ma'am, if you are able to connect with us and share your presentation, kindly start with it.
Yes, sir. Okay.
Okay.
Is my screen visible?
Yes, ma'am, your screen is visible.
Okay. A very good afternoon to the session chair, Dr. Archana, and the fellow presenters. I'm here to present the research titled Development of a Flutter mobile application for real-time plant disease detection using convolutional neural networks and TensorFlow Lite, done by Dr. Sailesh Kamble, Ms. Tanisha Verma, and myself, Sakshi Sharma. The agricultural sector faces challenges in plant disease detection, which can cause significant crop losses. Traditional methods are slow, costly, and require expertise, making them unsuitable for large scale use. This study presents a real time mobile app using CNNs and TF Lite built with Flutter for offline functionality. The app enables farmers to detect diseases early, bridging the gap between AI advancements and practical agricultural applications to reduce crop damage. These are some of the research papers we refer to understand the existing work in the field. These studies validate that convolutional neural networks are a robust solution for real time agricultural disease detection, supporting the motivation for this research. So, for the implementation, the plant disease prediction model was trained on the new plant disease dataset sourced by through Kaggle. It consisted of more than 87,000 RGB images across 38 different plant and disease categories. The dataset was split on 80-20% for the training and validation. It also consisted of 33 test images. The images were pre-processed by resizing them to 128 by 128 pixels for uniformity. Then one hot encoding was used for multi-class classification. A batch size of 32 is used for a balanced memory efficiency and training speed. Moving on to the model architecture, the convolutional network model had 5 convolutional layers with filters from 32 up to 512. The max pooling layers for dimensionality reduction. We also introduced dropout layers of 25% and 40% to prevent overfitting. The fully connected layer had 1500 neurons with value activation function. The final layer had 38 neurons corresponding to the 38 categories, and softmax activation function was used. The plant disease detection application was developed on Flutter. The key features were that the farmers were able to capture or upload the images and view the results instantly. The local model inference allowed the farmers to use the app without internet access. The image preprocessing was done by normalizing, resizing, and formatting for inference. After uploading, the farmers can receive the diagnosis and treatment recommendations. The result, the CNN model for plant disease demonstrated a high efficiency, achieving 99.30% training accuracy and 96.93% validation accuracy. Overall accuracy was 97%, and the precision, recall, and event score were also 97%. Key findings were that the model generalizes well across multiple plant species and it successfully runs inference offline, ensuring accessibility in rural areas. The training loss decreased from 1.362 to 0.053, and the validation loss dropped from 0.537 to 0.105, indicating strong generalization of the model. On further analysis, we observed that corn blight and grape leaf blight showed high precision, recall, and F1 score, whereas tomato early blight and tomato late blight had comparatively low performance due to the visual similarities. The confusion matrix confirmed minimum class misclassifications with high true positives and low false positives. To conclude the presentation, we can looking at the future improvements, we can include or expand more images and expand the dataset to include more plant species. We can integrate weather and soil data for better forecasting. And with this, I conclude the presentation. These are the citations and references. Thank you.
Thank you so much, ma'am. We have a comment from our session chair. Go for real-time data set rather than available data set in Kaggle. That will be your real contribution.
Okay, sure, ma'am. We'll surely work on it.
Okay. Ma'am, do we have any questions for them? Okay, no. So now we would like to call upon the presenters we requested for before, if any of them are present. I'll just call out the presenter's name and their titles. If you are present, I request you to kindly take over with your presentation. Shubham Kadam, if you're present, sir, we request you to kindly take over with your presentation. Utkarsha Vanjari. Okay. Prashant Vats, if you are available, I request you to kindly take on to the presentation and let me know if you're available. M. Nanda Kumar, if you are available, I request you to kindly let me know. Okay. Looks like all the rest presenters are not available with us right now. So we like to wind up the session. Okay. Okay. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough We, on behalf of the whole team, thank you for your support during the ninth version and all the 8 previous versions of this conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certifications through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I will also like to thank our session chair, Dr. Archana, for sessioning our chair today. Here is a token of our appreciation for chairing our session, ma'am. I'll just display the certification. Thank you so much, ma'am, for chairing the session. Even with the problem with the mic, you still were patient with us. Thank you so much, ma'am. Ma'am has written great honor to attend this session. Thanks to organizing committee, helpful for researchers who are working in the area AI and blockchain. Thank you so much, ma'am. Now I just request all the presenters and all the people available in our meeting, along with our session chair, to kindly switch on their cameras for a quick snapshot of this virtual session. Okay. Everybody who's available, I request you to please switch on your cameras for a quick snapshot. Thank you so much. Now we can all log out our session, and we'll meet in the next session in 2026, hopefully. Thank you so much for your presence today. Thank you.